Hello everyone, and welcome back to another GIS mathematics tutorial video. And in this video, I want to continue our discussion on sort of outlining the basic definitions of an ellipse. So in the previous video, we talked about what it meant to be an ellipse, and we talked about these two focal points. We talked about some distances and how every point on this blue line basically has a constraint where if you add the distance between one focus, the point, and the other focus and the point, that distance, that summed distance, is going to be equal for every single point on the ellipse. And that's what it means to be an ellipse. And then again, we sort of defined that those 2 points that anchor the ellipse, right, they're called foci, or focus points. And then we talked about the 2 axes, right? So you can imagine having some lines that cut the ellipse into pieces. One line going sort of left to right or horizontal, that would cut the ellipse in half, top and bottom. And you can have a line that goes vertically that cuts the ellipse in half, left and right. And we sort of made the definitions that if the ellipse is longer, that if the line that cuts through it is cutting through it in the longer direction, then that line is the major axis. And if the line is cutting through it in the shorter direction, then that line is the minor axis. And one thing that we didn't sort of specify, and we probably should have, is that these lines are horizontal and vertical, right? So this is a vertical line, this is a horizontal line, and that they are perpendicular to each other, meaning that they intersect in the sort of center of the ellipse at a 90-degree angle. Which brings me to one more term I want to talk about, which is actually the point where the 2 axes intersect. Actually, let me make that a little bit bigger first. At the point that these 2 axes intersect, we call that the center. We call this point where they both intersect, we call this the center. So let's go ahead and write that down. Let's add that to our definition, right? So I'm going to slide over a little bit, and we'll come back and look at the diagram here in just a second. I'm going to slide over. Our next term that we want to add in here is center. All right, so the center is where the major and minor axes intersect. Right, where those horizontal and vertical lines that cut the ellipse into pieces, right, where they cross over each other, that is the center of the ellipse. And again, the major and minor axes always are horizontal and vertical, and they always intersect at a 90-degree angle. They're perpendicular to each other. So that's the center. There's 4 other key points on the ellipse that I want to make sure that we understand. And I want to make sure that we understand the difference between them. So the next set of points I want to talk about are on the major axis, right? So again, this is the line. It doesn't have to be horizontal, right? If this ellipse were flipped 90 degrees, right, then this vertical line would be the major axis. But in this case, right, the major axis is the horizontal line, because the major axis is the line that cuts through the ellipse in the long direction. So the next 2 points I want to talk about are the points where the major axis intersects the ellipse. So that would be this point right here. Let's make that a little bit bigger. All right, that would be where this point right here and this point right here. Those 2 points, right, these are your vertexes. This is a vertex, and this is a vertex. All right. And so I want to scroll back over for a second and write down our definition of what a vertex is. So a vertex vertex, simply put, this is where the major axis, and I'm going to put major axis in blue just so we keep everything nice and color coded. This is where the major axis intersects the ellipse. And in case this wasn't obvious, right, there's two places. So there's two vertex. Right. So hopefully that makes sense, right? Just again, look back at our graph for a second here. Right. The vertices or the vertex are the places where the major axis intersects the ellipse. So now you might be saying to yourself, well, what about the minor axis? The minor axis also intersects the ellipse. And you're right, it does. And the thing is that they get a slightly different name. Right? The minor axis intersection points get a slightly different name. Right? This point and this point get a slightly different name. These are called covertex. Right? These points, again, where the minor axis intersects the ellipse, these are called covertex. Okay, so let's slide back over and let's write down our definition, and then we'll come back and just look at it one more time because this is really an important distinction. So we've talked about vertex, now we're talking about the covertex. So the covertex are where the minor axis, right, where that minor axis intersects the ellipse. And again, right, just like with the vertex, and you saw this, right, there's two places. So I want to sort of reiterate the idea here that we use the term straight line to define major and minor axis, right? We didn't use horizontal or vertical. And we used major axis and minor axis to define vertex and covertex. And what I want to do in the next video is sort of reiterate the idea that an ellipse does not have to be just fatter than it is, or fatter than it is tall, right? We could rotate this thing 90 degrees and that would still be an ellipse. But the major and minor axes and the vertexes and covertexes would flip. And again, we'll look at an example of that in the next video. But for now, hopefully you were able to follow along. Hopefully you understand the different definitions and and where they come from, right? What the focus points are, what the vertexes are, the difference between a vertex and a covertex, and the difference between the major and minor axes. If any of this was confusing, I strongly encourage you to pause the video, go back, rewatch the parts you're confused about, and as always, please reach out. Thank you.